Right, good morning. So we have finished discussing the special methods to construct the ellipse, right? So now the other conic section is parabola. So there are three methods. Let us discuss three methods at least. Three methods to special methods for constructing parabola. So they are rectangle method, we call it as oblong method also. Oblong method. Do you have notebooks now with you, pen and paper, all that? Because in your group I have posted to be ready with pen and paper. Because sometimes you need to, when I say you, better you note down the things wherever it is required, right? So this is oblong method or rectangle method is one. The second one is parallelogram method, and the third one is tangent method, right? So for that, let us take the first one. By rectangle method, let us construct the parabola. So let us straight away, let us take a specific question. What is that question here? Just read it. I'll read it. A ball thrown in air attains 100 meters height and covers horizontal distance 150 meters on ground. Draw the path of the ball. Draw the path of the ball or any projectile. Ball, stone, bullet, anything like that. So here it is. Read once again. A ball thrown in air attains 100 meters height and covers horizontal distance 150 meters on ground. Draw its path. So there are two parameters given. A ball is thrown. So let us here. Any ball or any object which is thrown at certain angle other than the vertical, other than the 90 degrees to the ground, thrown at an angle, not 0 degrees, not 90 degrees. Between them, any angle if you throw that, because of the gravitational pull, it takes or it traverses a parabolic path. That is one. So very, very, very important, because here in the data, parabola is not mentioned. You need to get that, you need to have that. You don't need to be anxious, right? Don't get confused. Whenever a ball is thrown, it takes a parabolic path. Because of what? Physics, we know that. It takes a parabolic path. So here, two parameters have been given. In relation to or with reference to the parabolic parameters. How to use this? What does indicate? This horizontal, what to take? Horizontal distance is to be taken what? And because parabolic path or parabola to be constructed by rectangle method, we need base and axis. We need base and axis. What is given here? These are the construction steps. So let us see. Because the name itself is suggesting rectangle method, na? So that's why here the rectangle is drawn here. So let us go. I'll just put some marks. You can, if you want, you can note them down. Whenever this type of problem is given, the horizontal distance covered by that projectile is to be taken as the base of the parabola. Always. Horizontal distance covered by the projectile is to be taken as the base of the parabola. And the maximum height which it attains, here it is 100 meters height. So that is to be taken as the axis of the parabola. Two things, horizontal distance, base, and the vertical height, maximum vertical height from the ground it achieves be taken as axis. So with this base, that is here in the data 150 meters. 150 meters, meters means it's a very big measurement. Our drawing sheet is not sufficient. And do you remember? You get to the thing, what is the drawing sheet size? Did you follow them? Do you remember them? Where it does start? The basic drawing sheet size is A0. And what is the size of it? 1 square meter only. The maximum size of a drawing sheet size, that is the basic size, let's say, A0. And we are not using A0, we are not using A1, we are not even using A2 as well. Our size of drawing sheet of our measurements, it is very different. It's not even A2, not even A3. I think it between A3 and A4, you calculate that. A0 size is 1 square meter and A1 size is half of that, that is half a meter square. And A2 is obviously half of that, this is 1/4 square meter, and A3 obviously 1/8 square meter, like that, it goes on like that. With the length and breadth bears a ratio of √2:1. The rectangular size, drawing sheet size is rectangular size, so obviously length and breadth. The length and breadth of each drawing sheet, any category of drawing sheet, bear a ratio of √2:1 always. And the total area will be reduces by half, successive, reduces by half, so you will. But here it is given, so overall A0 size drawing sheet size is only 1 square meter. But here you look at the sizes, 150 meters, the horizontal distance covered by the ball throw. 150 meters should be reduced to the size in such a way that it should be reduced in such a way that our drawing sheet should be sufficient to represent this phenomena or this event. What is that event? Event is ball is through and it is covering certain horizontal distance. It is achieving. Finally, it is traversing a parabolic path. That is our interest to trace that parabolic path, right? So, in order to represent that event here and this, we have to reduce the sizes so that that is clearly represented on the drawing sheet. So let us take like this, 150 meters be taken as 150 meters. 150 meters be represented by 150 millimeters. That is 1 meter is equal, 1 millimeter on the drawing sheet is equal to 1 meter original distance. So that is, you are reducing the sizes given by a ratio which is called scale factor, you know it, and is a representative fraction, you know it, that is what we are reducing it by 10 power 3 times. So what is the scale factor here? 1:1000. 1 millimeter is representing 1 meter. So 1 meter consists of 1000 millimeters. So let us draw it by. So horizontal distance, let us represent it by 150 mm means 15 centimeters on the scale. And the height we represented by 100 meters, that is we represented by 100 mm, that is 10 centimeters. So let us draw the rectangle. The horizontal size is 15 centimeters, 150 mm, and the vertical, let's take it as height or breadth, that is that by 100 mm, 10 centimeters. We have to complete the rectangle as the name suggests, we get the rectangle, taking base and axis as the two sides of the rectangle. And now find the midpoint of the length, let's say, from there, write a vertical line. Thus, the rectangle is divided into two equal parts. And you can name it, or else you can go straight away for this construction. Now, just look at the figure. Just look at the figure what I am doing here. I'm dividing that vertical side, left-hand side vertical line is divided into certain number of equal parts. Let's count them. 1, 2, 3, 4, 5, 6. I think it is divided into 6 equal parts. Yes, it is divided into 6 equal parts. If somebody wishes to divide it into 5 equal parts, there is no problem. Somebody wishes to, depending upon the size, somebody is it, why 5, why 6, I go for only 4 because the size is less. Okay, you can go for 4. Somebody might, I want to get an accurate parabola, a beautiful parabola, I'll take more because I've got time, sir. Okay, you can go with that also. So divide that vertical line, and in the same way, the horizontal line, half of the horizontal line up to that point of the bottom. Divide the vertical line and this horizontal line into certain number of equal parts. We have divided this vertical line into 6 equal parts. In the same manner, you have to, there is no other goal. You have to divide the horizontal line, half of the horizontal line of this rectangle also into 6 equal parts. If you are dividing into 5 equal parts, divide both the vertical and horizontal line into 5 equal parts only, and always do remember, get these equal divisions by geometry, don't measure there. Right, that would be leaving some impression on the person who is evaluating your drawing, or the person get impressed who is reading your drawing, right? So division is over. Now name the points as shown in the figure. Name the point as shown in the figure, and you need not give that 6. Okay, let's say now for the horizontal. So just look at that. We are starting from the left bottom corner, right? We are moving away from it for both the division points on the horizontal line, division points on the vertical line. We are giving the names. We are moving away from the bottommost left bottommost corner. From that, we are moving on to the right for naming the division points in the horizontal line. And we are moving upwards for giving the names for the division points in the vertical line. So just keep it like that one. Don't go other way. Right? Now join these 1, 2, 3, 4, 5 with the top end point of that axis. We can call that as axis, right? That is one. Do it very accurately in order to get a beautiful parabola. It's very simple in construction, but only thing is in practice we have to be accurate. And from the 1, 2, 3, 4, 5 is the horizontal line, right verticals. Okay, divide on the other. Join them also. Like same. That is similar, identical work in the second half, right? So now from here. So from vertical line from 1, 2, 3, 4, 5 on the horizontal line to meet the lines joined or drawn from 1, 2, 3, 4, 5 on the vertical line to the top end of the axis. Like this, just follow the figure. You should not miss in the middle. There should be some correct sequence. Because there are so many lines have been drawn, so you must not miss. The vertical line drawn from 1 should reach the line drawn from the point to 1 on the vertical line. Just look at 4. I think after 1, 2 points, you will get it right. I need not tell elaborative. Highlight those points which are to be connected. And there is a maximum more number of students will be making mistakes. They won't join the 2 points of the bottommost horizontal line, which is the base, because base is given as 150 mm or 150 meters distance covered by the projectile, right? The ball. So that is the base. So you need to include those terminal points of the base, first horizontal line that we have drawn. So now connect these points with a beautiful freehand sketch. Definitely you'll get stunned by the beauty of the figure, right? And again here, obviously you need to write the dimension lines for that 150 meters. Here we have taken 150 mm and 100 mm, but while writing the dimensions, you write the extension lines and dimension lines 10 mm away from the main figure, obviously, for both the directions, both the dimension lines, and put the digits 150 meters. You write here, normally we'll be writing in column. Mm only. We don't write, we write just digits, but here you put 150 m meters. And there for the vertical line, that is for the axis, give the dimension as 100 meters. And below the figure, you write that in a small rectangular box, you put 1:1000, because we have taken 1 mm line on the drawing for 1 meter of the original distance that the ball is covering. So that is 1:1000. 1 millimeter on the drawing is equal to 1000 millimeters. That is 1 meter of the original distance. That way, just below the figure or just besides the figure. Right? Don't write scale factor, all that. Just put a rectangular box lightly and 1:1000, right? And that will give the end of this construction of the parabola by rectangle method. Also, it is called oblong method.